Hello everyone, visible my screen?
Yes, sir.
Yes, sir.
Visible, okay, fine.
Yes, it is there in the book, but I don't know. Is it the previous one or the final one? I will put it today again. I will check in the group that is it the final. I think it was one or two. I think is missing.
Okay, we can start. Okay. So, hello everyone, audible my voice?
Yes, sir.
Okay. So, last class we are discussing from the classification of continuous time systems. Okay. So, classification of continuous time systems are 6 types. Already I discussed
Yes,
the previous class. So, first one is the static and the dynamic system. Second one is the time invariant and time variant system. Then after that,
when we started.
after that, we can discuss from the time variant and time invariant system. Then we can discuss from the linear and non-linear system. And fourth one is the causal and non-causal system. Fifth one is the stable, unstable system. Sixth one is the feedback and non-feedback system. So in that way, we can last class we can complete from the static and the dynamic systems with example. Similarly, from the second one is also complete time invariant and time variant systems. Okay, then we are using example also the time variant and time invariant examples. Okay, next come to the third classification. It is known as linear and non-linear systems. Okay, so linear and the non-linear system. So we can discuss what is the systems of the linear system and non-linear system with example. So I already told that the previous class in the you are already been study from the network theory, okay, subject. So in this network theory subject, one is the superposition theorem. Already we are studying, okay. So in the linear system is one that satisfy the superposition theorem, okay. So superposition systems is satisfied, so that system is known as the linear system. So now come to the what is the principle of a superposition theorem. The principle of a superposition required so the principle of superposition requires that the response of a system to a weighted sum of the signal is equals to the corresponding weight sum of the response of each of the individual input signal. So this is the statement of a superposition theorem. Already we are studying in the second semester, I think that third semester, that is the network theory, okay. So that I can overwrite once again.
Okay, hold on.
So the principle of a once again I can call that the principle of a superposition requires that the response of a system to a weighted, okay, weighted means multiply with some factors of this is known as weighted sum of the signal is equals to the corresponding weight sum of the response of the each of the individual input signal. Means corresponding sum is equals to the response of each individual sum of the input signal. So let's come to the mathematically expression of the superposition theorem. So look at these are the two things is there. So first one, the relaxed system of this one is the known as the operator, or the system is linear if. So this one is known as the operator, means the system. So A1 is the weighted of input signal x1 of t plus A2, which one, right? So next one is A2 is the weight of the second input signal x2 of t, okay. So this is the curly bracket is given, that means the whole input signal x1 and x2 summation of the system response, that means it is known as the corresponding weight. So first one, this is known as the corresponding weight. So this is known as the corresponding weight. So this is the operator. This is known as the corresponding weight of this one is equals to the individual weight. So look at this. सर मेरा क्लास चल रहा है, क्लास के बाद कॉल कर रहा हूँ सर. हाँ, so next one is the this one is the A1 into h of x1 of t plus A2 h of x2 of t. So that means these are the individual response of the system. X1 of t plus x2 of t is also the individual response. Summation is equals to the corresponding response of the two signal. So look at this curly bracket is even from the use of this operator. This is known as the system response is of the corresponding, means x1 plus x2 signal whole response is equals to individual response. Look at this is h is only used for x1 of t. This h is used for x2 of t. So that means this one is the individual response of the two signal is equals to the corresponding response of the two signal. So this is equals to, when this is equals to, then it is known as the linear system, or this is, that means this condition is the superposition theorem condition. So when the superposition condition can be obeyed, that is known as the linear systems. Okay. Now come to the problem. Okay. So if the relaxation system does not satisfy the superposition principle, as given below definition, the system is non-linear systems. Okay, that means that not be equals to this one. So that means automatically that system is known as non-linear systems. Okay. So now that can be, we can more clearly you can use from the diagrammatically. Okay. So diagrammatically we can solve, that is the symbol. So now come to here. This is the two symbol. That is the more easier than the mathematical equation. Look at. So come to the left hand side. This is the equation of the superposition theorem. Whole response is H A1 x1 of t plus A2 h2 of xt. Okay. So now come to this one is x1 of t input signal. This is x2 of t, another input signal. Okay. So now this one is known as weight of x1 of t input signal. A2 is the weight of x2 of t signal. So after that can be multiplied A1 into x1 of t. Then A2 is multiplied with x2 of t. So then these two signal is summation. This is the symbol of summation. So plus these two signal A1 x1 of t plus A2 x2 of t. Now that signal is entered into the system, because this one is the symbol of a system. H is the symbol of a system. So that two signal is entering into the system. After that, we are finding this one is the system response x1 A1 x1 of t plus A2 x2 of t. So this is the output response of x, that is the system. So now come to the this one is the equation. So this is H all of A1 x1 of t plus A2 x2 of t. So this is the output response of, this is the systems. Okay. So this one is the first condition is satisfied. Now come to the second diagram. Okay. So now this is the corresponding response diagram. This one is the individual response diagram. Now x1 of t is entering to the system. So this is known as the H. So after that you can find that is the H x1 of t. Now similarly x2 of t is also entering to the system. So then we can find H x2 of t. So now it's multiplied with a weight A1. So A1 into H of x1 of t. Next is A2 H of x2 of t. Okay. So now the combination of these two, A1 H of x1 of t, A2 H of x2 of t. So then we can, summation is symbol A1 H of x1 of t plus A2 H of x2 of t. So now come to this one is the formula right hand side. Look at this one. Okay. So A H of x1 of t plus A2 H of x2 of t. So now this is the diagrammatically expression of a linearity system. Okay. So it is easier, we can understand point of view. So now come to the different examples. So before we come to the example, so come to the procedure to test for the linearity. Okay. So this system is a linear system or non-linear system, we can test it. Let x1 of t and x2 of t be two input to the system H. Okay, H means the system, and y1 of t and y2 of t be the corresponding response. Okay, so if the two input signal is given to the system, then the output must be y1 of t and y2 of t is there. Now consider a signal x3 of t is equals to a1 x1 of t plus a2 x2 of t, which is weighted sum of x1 of t and x2 of t. So let y3 of t be the response of a x3 of a t. Okay. Then check whether y3 of t is equals to a1 y1 of t and a2 y2 of t. If the equation, then the system is a linear or otherwise. So this is the procedure from the test of the linearity. Using this procedure, we can solve the problems with the use of a diagrammatically method. Okay. Come to how to you can solve just for all these things. Okay. So now the example, test the following system are linearity systems. Okay. So example is y of t, that means output response is given, that equals to t x of t. Okay. So then given that y of t is equals to t x of t. So according to our formula, that is the y of t is equals to, this one is the operator, that is x of t, or that is equals to t x of t. Okay, this is very important. Okay, so y of t means that one is the, that y of t is the output response of the system. So that means the system, so h is multiplied with x of t. Okay, so that is equals to t into x of t. Okay, so that is already been given here problem. Look at this is the problem. So now consider two signal x1 of t and x2 of t. Okay, so from the, according to the superposition theorem, so two signal is there. Then one x1 of t, that response is, output response is y1 of t. Then x2 of t, that output response is y2 of t. Okay, now y1 of t, so the output response is h into x1 of t. So that can be also, we can retain as t into x1 of t, because we know that this is the problem which is given, the y of t is equals to t into x of t. So in place of x of t, we can write x1 of t, because we are finding y1 of t. Then similarly, y2 of t is equals to h of x2 of t is equals to t into x2 of t. Okay. So now our main intensity to compare the linearity of the system. So then the individual response is y3 of t is equals to a1 x1 of t plus a2 x2 of t, because this is x3 is the so this is the individual response we are finding. So now we can find next one is the, because the condition is there here, the individual response is equals to corresponding response. So in that problem we can find the individual response one by one. Now we can find the corresponding response, then we can equal it. So now this is the corresponding response, x3 of t is equals to x1 of t plus x2 of t. A1 and A2 are the weighted of the input signal. First input signal x1 of t is into A1 and x2 of t is A2. So this is the corresponding signal of a input signal. Then that corresponding input signal is passing through the system. Then we are finding the response of the corresponding system. So y3 of t is the response of a x3 of t. So this is h of x3 of t is equals to h of a1 x1 of t plus a2 x2 of t. Okay, so now the formula which given that t. So in place of h we are written this is t a1 x1 of t plus a2 x2 of t. So look at here. Previous example t is individually multiplied with the x1 of t and x1 of t. But here t is the corresponding response. That means that t is multiplied with the corresponding signal. So now this t can be also multiplied. So t a1 t this one plus a2 this t. Okay. So that is a1 y1 of t equals to a2 y2 of t is also. That is the same thing because t is where does not be using, that is the also same. So y3 of t is equals to a1 y1 of t plus a2 y2 of t. So the given system is a linearity system. So look at the individual response, that means that is the x2 of t plus x3 of t. So look at this one is equals to of this one. Okay, these things are same. Here the individual response, it means this one plus this one is equals to, from here is also, here is weight is not there, so weight can be where multiplied, so then the result is the same. Okay, so that's why the system is known as a linear system. Is there any doubt? You can ask me. Okay. Next, we can come to the second example. So here is there x, the output response y of t is equals to x of t square. So then we can find directly y1 of t is equals to h of x1 of t. So that means x1 of t square. So now similarly y2 of t is equals to h of x2 of t is equals to x2 of t square, because we find that y of t. So these are the individual response. That means x1 of t square plus x2 of t square. Similarly, now we can find the corresponding response. So as x3 of t plus a1 x1 of t plus a2 x2. So that corresponding signal is now the system. That is y3 of t is equals to h of x3 of t is equals to h of a1 x1 of t plus a2 x2 of t. So then we can find that a1 x1 of t square plus a2 x2 of t square. So that is equals to, that is a1 y1 of t, because this one is the output, we know from your equation. So y1 of t, this one is the y2 of t. So now we can find that this one is the equation 1 and 2 is equals to from this equation. So that is the y2 of t is equals to a1 y1 of t plus a2 y2 of t. So this given system is a linear system.
It means those are not used. So how to represent those? So those type of variable combinations which are actually not used in a particular application. So
Next come to another problem, that is y2 is equals to x square of t. So here is y01 of t is equals to h of x1 of t is equals to x1 of t square of t. Then y2 is equals to similarly h of x2 of t, that is equals to x2 of square of t. Then x3 of t is equals to a1 x1 of t plus a2 x2 of t. So then y2 of t be the response of the system h for the input x3 of t. then y3 of t is equals to h of x3 of t. So h is into a1 x1 of t plus a2 x2 of t. So then we are finding that a1 x1 of t plus a2 x2 of t, this whole square. So now that whole square we can find. So that is a1 square plus h1 square of t plus a2. This one is the a2 into a1 plus this one. So now a1 y1 of t, this is the this one. Now the equation that is the y of this is the signal of the corresponding response, but the individual response is the different value, that is h1 and y1. Output is y1 of t. So this one is the x1 of t square plus x2 square of t. So now, but the corresponding response is the difference. So this term is the additional term from the corresponding response. So that this system does not satisfy the superposition theorem. So that means y3 of t, this is y3 of t, does not be equals to the individual response, that is a1 y1 of t plus a2 y2 of t. Okay, y2 of t. Hence the system is nonlinear systems. Okay. Next. So this is the y3 of t, and that is the y1 of so this is y2 of t does not be equals to a1 of this. So this system is known as nonlinear system. So now come to the third one example. We can solve this one is the third example. Okay. So now the y of t is equals to a x of t plus b. Okay. So now consider the two signal x1 of t and x2 of t. So y1 of t and y2 of t be the response for the systems h for input x1 of t and x2 of t respectively. So y1 of t is equals to h of x1 of t is equals to a x1 of t plus b. Why this one is we are finding this term? This term we are finding. This is the given equation. So that means the output response y of t is equals to a x1 of t plus b. So y1 of t is equals to h x1 of t is equals to a x1 of t plus b. Then y2 of t is equals to h x2 of t is equals to a x2 of t plus b. Then x3 of t, that means the corresponding response that we can find. A x of x3 of t is equals to a1 x1 of t plus a2 x2 of t. Then output is the y3 of t with the response of the system h for the input x3 of t. So y3 of t, that means the output response of a x3 of t. Y3 of t is equals to that is the system's x3 of t. That means the response of this one is the input signal is h of a1 x1 of t plus a2 x2 of t. So that equals to a1 x1 of t plus a2 x2 of t plus b. So that equals to a is multiply with b here. So a x1 of t, this one is the a x2 of t plus b. So then we are finding this one is the a x1 of t plus a2 a x1 of t plus b. So that means we can find that is the a1 y1 of t minus b. Okay. That means this one is the response of y. So that is y1 of t minus b plus A, this one is the y2, so y2 plus b minus b is there, plus b. So this is the response. So look at the previous one is the a1 x1 of t plus b, but here y1 of t minus b is there. Okay, so then y2 minus b is there plus b. So then is the output signal of this is y1 of t, and that is y2 of t is the different value we are finding the output. So that's why that system does not satisfy the superposition theorem. So that's why this system is known as nonlinear system. Now, this is the last example of the linear or nonlinear system. So first one, this one is the y of t is equals to x to the power t. So here similarly we can take the individual response y1 of t is equals to h of x1 of t, that equals to e to the power x1 of t, because this one we are finding the output signal. Similarly, y2 of t is equals to h of x2 of t, e to the power 2 of t. So now this one is the individual response. So summation of this signal we are finding that is the individual response. Now come to the corresponding response, that means the combination of the two input signal. So a1 x1 of t plus a2 x2 of t. So then we are finding the output response y3 of t of the combination response. So y3 of t is equals to h of x3 of t is equals to h of x1 a1 x1 of t plus a2 x2 of t. So that equals to e to the power. So according to the formula, a1 x1 of t plus a2 x2 of t, that is e to the power a1 x1 of t, then e to the power a2 x2 of t. So then we can find which one is this one and this one. So y1 of t, that is y2 of to the power a2, but here is only x1 of t and it is y2 of t. So then this individual response summation does not be equals to this summation. So that's why this system is known as nonlinear system. It is also we told that this system does not be satisfy the superposition theorem. So superposition theorem is told that the corresponding response is equals to the weighted of a individual response. So this one is things does not be satisfied this example. So that's why this system is known as nonlinear system. So from here above A and B, okay. So this problem, A and B are a linear system because they are satisfy the superposition theorem, and C, the problem C, D and E does not satisfy the superposition theorem. So that's why the left hand side and the right hand side equation does not be satisfied. So that's why that system is known as nonlinear systems. Okay, these are all about the linear and the nonlinear systems. Is there any doubt? Then ask me. Then
how many you are using for BCD? You are using 10 only. Remaining 6, are you using?
Then I come to the another type of classification. This is known as the causal and non-causal systems. So come to.
So these are the don't care.
It's not required for you. If someone can be study more, so then we can. I already added from the two separate equation from the linear and the non-linear system. We can also study what this. Now come to the causal system and non-causal system. Very easy things. A system is said to be the causal if the output of the system at any time t depends only on the present input, past inputs, and the future outputs. Okay, so three things.
meaning of
if a system's output
the combinations
at any time t only
variable combinations
on the
which
present
include,
input,
therefore,
past input, and the past
a
output, but does not depend on the future inputs and the future output. That system is known as a causal system. And if the system output at any time t depends on the future input or the output, then the system is known as non-causal system. So that means we know that the system's output depends upon present input, past input, and the past output. That system are the causal system, but does not depend on the future parts, that is the future input and the output. That system is known as causal system. And non-causal system, the future input or the output when the system is known as a non-causal system. Let's come to the example. We are more clear about this. Okay. So this is the causality test of the following system. Very easy. Okay. So let's come to the first one. Y of t is equals to x of t minus x of t minus 0. Okay, so we can start from 0. So t is equals to 0. Okay, so t is equals to 0. Why we are starting from the t equals to 0? Because so we can check it first. This is the, so someone will tell you that, sir, I am starting from the minus part also. Minus t, 1, minus 2, minus 3 also. So why we are starting from the, this one is the t is equals to 0. So this is the question. So here look at where we are putting here minus 1 or the minus 2. So then that value is, that is the we are finding, that is the minus 2 we are finding. Okay. So this is also minus 1. So that's why we can find that is the t equals to 0. So if that is the t value is something is there, that is I think 2, 3, then we can use that is the minus 1 or the minus 2 term. Okay. So in that way we can use from the here. So t is equals to 0. Then y, this t position we can put the value of 0. Then x position, this is value of the t value is 0. So 0 minus 1, that value is the x of minus 1. So that means the present t is equals to 0. That means the output response y of 0 depends on the present input. So present input means x of 0. Because output is 0, that means this is the present input is x of 0. And minus 1 term is there, that means the past input of x1 of t, x of minus 1 is there. Now, so is there any doubt? Minus term means this one is the past. 0 means term means the present. Okay. So then t is equals to 1. So let's look at another example. You can take t is equals to 1. So y1 of 1, x of 1, that is minus x of 0. So then the response of t is equals to 1, that is y1 of 1 depends on the present input x1 of 1 and the past input, that is x2 of 0. So from the above analysis we can see that for the any value of t, the system output depends on the present and the past input. Hence the system is known as the causal system. Okay. Now come to the second one. Because we know that the causal system depends upon the present input, past input, and the past output. So that system is known as the causal system. So in that the output responds the present and the past input. So that's why the system is a causal system. Okay. So now come to the given that the y of t is equals to x of t plus x or 2x t1 t minus 3 minus t. So now we can check. So I already been told that the previous example. So the t place we are using the number we are coming. So we can use the -1 term first. Okay. So then t is equals to, in place of minus, so that is the y of -1. Then x of -1, then 2 in plus of -1, that means that is the plus. So +1, and this one is the 6. So this means the 4. Similarly, we can use the 0. So x of 0, 2, x of 3. Similarly, we can use 1. So that means -3. So that is in place of 2, minus then 2. So that one is the x y of t is place of 2. Then x place is that is x of 2 plus 2. X 2 is minus, then x of 1 is there. So first one we can find that the response t is equals to -1. Then output response y of -1 depends on the present input x -1. Then the future input x of 4 is the future, because positive is come to the future. So now is it the x, so x second one, y of 0 depends on the present input x of 2, then the future input x of 3. Similarly, the response t1 is 1, y1 of 1 depends on the future present input and the future input x of 2. Similarly x of 2, y2 of 2 depends upon the present input as well as the past input. So the above analysis we say that t is less than 2, the system output response present and the future, and the system is non-causal system. So the non-causal system, so look at here, the 1, 2, 3, 4. So 4 cases we can take the t value -1, 0, 1. In this above 3 condition, both the output system depends upon the present input and the future input. Okay, and the last case we can the output response depends upon the present input and the past input. So this is the condition of the causal system. So causal system condition, the output can be depends upon the present input, past input and the past output. Okay, but the majority cases, they are the present input and the future. So future terms is come to the majority condition. So that's why this condition is the non-causal system. Non-causal condition is that depends upon the present input and as well as future input and the future output, also the present input. So future input, future condition is coming, so that means this system is a non-causal system. Okay, so now come to third one. So when x of 0, y of, so here is not 3 term is there, so that's why 0 we are using, then 1 you are using, then t is equals to 2 we are using. So when we are using t, so the output response only present input, so t1 is using the output response present input, then t2 is you are using output response is the present input. So obviously we can tell this one is the causal system. Future term is does not be coming. So according to that we can tell that this system is known as a causal system. Now come to the another example, y of x of t plus integration of 0 to 2x of lambda dt. So now we can use here the after the integration, this term I will be taking the integration, so we can got that x of t, z of t minus z of 0. Okay, so this is the integration of the x of lambda. Okay, so now we can put this equation from the t equals to 0. So then we can find this one is 0, 0. So then y1 using the also this term, then t is equals to 2, then we get this one. So look at here. So t equals to 0, then the output response y of 0. So this is the output response y of 0. That means the present input. All are the 0. That means the present input. Next one is the t is equals to 1. Y of 1 is depends on the present and the past input. Similarly, t is equals to 2. Y of t depends on the future and the past input. Okay. So the above analysis, we can say that the response for the any value of the t on the present and the past input. So the system is a causal system. Now come to last one. We can discuss similarly x of t integration of 0 to 3t x of lambda d lambda. So y of t is equals to x of t plus 0 to t x of lambda. So d lambda. So x of t plus this, I can take the integration of this term. So after solving this one is the z of 3t minus z of 0. So we are t is given. So y of 0, x of 0, z of 0 minus z of 0. Then the response t of t is equals to output is depend on the present input. Similarly, we can put the 1. So y of 1, x of 1 plus z of 3 minus z of 0. Then the response t is equals to 1 is, that is y1 of 1 depends on the present, past and the future input. Similarly, in the t cases, t is equals to 2. So then the output response y of 2 is equals to x of 2. So x of 2 and the z of 3, these are the future term, and z of 0 are the present term. So obviously that is y of t is a present, past and the future term. So that means that this is the non-causal system. Okay, so in this case we can look at this first one is only satisfy the condition of a causal system, and the last two T1 and 2 does not be satisfy the causal system condition. So the majority condition are the non-causal system. So that's why this system is known as a non-causal system. Okay. So is there any kind of doubt? So ask immediately. So this one is the very important. So now come to the given y of t is equals to x of t plus x of t divided by t. So y of t is equals to x of t plus d derivative, this one. So now add 2x of t, limit this one, you can derivate here. Okay.
And express it using product of sums.
Okay.
What we do? Here we will group the zeros, and for making the group.
So take the limit of the definition. So the above equation of any value t. So x of t is present the input, and x of t minus del of t as the output input. So therefore we can say that the response of any time of t on the present and the past input. So hence the system is a causal system. So because the differentiation term is coming, so that means does not be the future term. So we are easily told that this system is a non-causal system. Okay. So I'm already setting from the other example, so you can practice in your home. I can provide for them by the mail, all of you. Okay. So these are the. Is there any doubt? You can ask me.
So here in this way we have finished our this chapter. So here in this chapter we have learned in detail about all the.
Or otherwise we can. So no doubt. Then in the chat box, the present you were given, then leave the meeting.
Then,
okay.
Suppose the expression is not given in terms of unit terms, then looking at those how to.
For the exam point of view, these things are very much important. Okay.
Yes.
So that's why we can read properly.
Looking at each term
and with examples.
That we have also seen. Then 4 variable came and we studied. Then 5 variable came and we studied. Then we studied the expression in sum of product form as well as product of sum form. And then finally we have understood the truncate conditions. We have also seen that how to implement the final expression that you get every time by using the logic gates. How to implement